Hey guys, it's been about 7 months now since I made a video, and the time has come, and you're going to see a lot more of these soon. So this is the beginning of a new series we're doing, specifically around comparing Holley to a stock computer and determining where one has an advantage over the other. And to be honest with you, for the types of cars we deal with, which is Fox bodies, small block Fords only, and to be honest, street cars, nothing, not these 1,500 horsepower, 2,000 horsepower race car or whatever. That's not really what we do. We deal with things usually that are in the, I'd say 300 to 700 horsepower range. There's a few outliers, but that's pretty common. But even some pretty beefy street cars. And we firmly believe that for most of those cars, and especially those with the stick shift transmission, can have much better drivability with the stock computer versus a Holley. And I've been in a ton of heated debates lately on Facebook, so much so that I actually got Facebook banned for the first time for 24 hours because they said I was bullying somebody, which fine. But the thing is, I come from a position of experience when I say I have these beliefs, and rather than trying to type out a novel every time somebody questions what I'm saying, I'd rather start a video series to show people what I mean. Because again, I do believe that my points that I'm going to make here are true, they're right, and I know why I'm frustrated with Holley. So in this first video, the first topic we're going to cover is why the idle air control is not so good because it's not linear. And Ford had a way to figure this out. It's very simple. They knew that, when you think about an idle air valve in terms of duty cycle, you have a range from 0 to 100% duty cycle. And all along the way through that progression, you have some amount of airflow. So as the duty cycle goes up, the valve flows more. As the duty cycle goes down, the valve flows less. And while that's true in all cases, across that range, it's not linear. So if you think about it, wherever you are in that duty cycle currently, adding 1% or removing 1% duty cycle will not equal adding 1% more airflow capacity or removing 1% airflow capacity. And depending on where you're already at, it's going to be very different. And that's a big challenge because, the way a stock computer did it is it was based on the actual airflow numbers, not based on just a generic duty cycle. So you could tell the system, I want this much more flow pounds per minute. I want 0.05 or 0.1 more or whatever. And there's all kinds of settings in the computer to do that. But you actually requested an airflow, a specific amount of airflow. And they were able to do that. And I'll show you why, because in a stock computer, they had a transfer function that helped the computer from the beginning understand when I need a certain amount of airflow, I know how much duty cycle to go to get to it, because they had this map that translates duty cycle to airflow. And with all of the measurements being in the tune, and I'll give you some examples of that, like right here. If we go look at how much air does the engine need to idle, it's in pounds per minute. It's in airflow, not duty cycle. How much does it need during driving? Airflow, not duty cycle. Now, and it goes on and on. There's tons of settings like that. What I want to do here is, rather than just bash Holley or tell you guys that stock computer's awesome, Holley sucks, and you're an idiot for doing Holley. I'm not saying that. But I want to give Holley's engineers some constructive feedback here that allows them to improve their product moving forward, so guys like me don't even have to have these complaints, and we can get better results tuning with their platform with less effort. Because that's really what they should be doing, supporting their users to get better results easier. That's the whole point. And let's face it, Holley's entire marketing pitch is, this is the plug and play, full harness, easy button, self-tuning, whatever. They're trying to sell you the easy button, but they're not always giving it to you. So here's what I think Holley should do. When you're a company like Holley and you grow very quickly in your user base, and that's exactly what they've done, obviously, you actually kind of back yourself in a corner. A lot of you guys might not know this, but I actually work at a software company. I'm a product manager at a software company, and the software's been in development for over 10 years. And we've gone through lots and lots of major releases. And the problem you have is that every single decision you make in a commercial product that goes to market, once it's generally available to the public and people start using it, you have to support your decision that you made in that version forever. So if you later down the road recognize, there's a better way to do something we're already doing, and you know what the better way is, you have to figure out a way to add that better way into your platform without breaking all of the people that are already using it. So if Holley just went in here and made some general changes to the idle air logic, every car that's already on the road wouldn't behave the same way, and you can't do that. I mean, that's like lawsuit type territory, because you are talking about people driving these cars on the roads and whatnot. So you have to, respect people's safety and not just make cars behave strangely just because you feel like it should be different. So what do? Well, let me show you what I think should happen. Basically, in the Holley software, when you set up your tune, one of the things you have to tell it is what type of idle air valve are you using. And because we deal with Fox bodies and Fords, the vast majority of people are going to use the stock 5-liter Ford idle air valve. Some people will not. Some people switch over to the Chevy stuff because they read that it works better or whatever. But you pick from a drop-down list. So going into the Holley software, here's that setting. Advanced idle control. You have a drop-down, and you can pick from the list. My recommendation to Holley is, rather than trying to change all of your other idle air logic across the board, you need to add a new option to this drop-down list. You need to leave the existing 5-liter Ford, and it needs to work the way it always has with no changes, but you need to add one new option called something like 5-liter Ford Linear. And by selecting that, what's going to be different is that when you ask for a certain percentage, like on the IAC hold position right here, or on your IAC park positions, it's not actually going to give you this duty cycle. It's going to translate that behind the scenes to a duty cycle that's linear. And I made a spreadsheet this morning while I was taking a poop, and thought you guys might want to see that. It was good toilet material for me. So let me jump over here. Kat, you need to move because I'm making a YouTube video. This is the second time you've done this to me. You're trying to be famous too, but you're not that special. You're a little ginger kitty, and you're mean. And I know if I try to make you get down, you're going to scratch me. So, go on. Go on. Go somewhere else. Okay. Anyways, guys, so that Ford transfer function that I just showed you on the other screen, I put that into the spreadsheet. Duty cycle on the right, 0 to 100%, and how much airflow that means on the left. Then what I did is I turned this into the same thing, but I made it a 100-point transfer. So for every 1% duty cycle, we have the airflow for that. You'll notice that at peak duty cycle, the total possible airflow from this valve is 2.35 pounds per minute. So what I did is I took that same number, 2.35, put that at 100%, but then I basically just said if it was a linear valve, we would have even numbers all the way down. So if I go down by 1%, airflow would go down by 1%. If I go down another 1%, airflow goes down by 1%, all the way till we get to 0, which would be at the bottom. And the way I envision this new valve working is that the users, once they select this valve, they're still going to be doing things in terms of 0 to 100, but behind the scenes, Holley is not going to necessarily request that duty cycle here. They're going to request something behind the scenes that yields that percentage of total airflow. And up top at the, top of the range, the error rate between what you would configure and what it would actually give you to make it linear, not such a big deal. But that's not really where the idle air valve is most important. It's most important actually at idle and decel, where you're in kind of the bottom half of the valve's range. So when I scroll down and look at that, you can see that difference in what I'm talking about is actually rather huge. Now it's in the 20 and 30% range through most of the valve's flow. So if I want, for example, 30% of the total airflow of this valve, I should actually open it to 56.6% of its duty cycle behind the scenes. And by doing this, you're giving users something that can actually follow your own instructions, because Holley, in your instructions, you tell people to adjust their throttle stop screw so that the idle air duty cycle at hot idle is, somewhere between like 0 and 10%. Usually you hear people talk about 5 to 10%. But you can't do that with the Ford valve in the way you do it today, because at 0%, the valve flows 0 airflow. At 5%, it still flows 0 airflow. And not until you get above 10% does it actually even start to flow any air. So with what I'm telling you guys, if you did what I'm saying, you would have it linear all the way from the beginning. If somebody wants to get to 5% airflow, they would actually get 0.11 pounds per minute of air. You would actually have air starting even at the first percent duty cycle, even though behind the scenes, that's already up to 27.6% duty cycle. See, Ford, they never let the valve close even below 17.5% duty cycle, which was actually just a tiny bit of air, but it was some. Then if they went up from there, they could get more air out of it. So using this function I'm talking about, a 5.0 liter Ford, linearized or normalized or whatever you want to call it, you would actually allow users to follow your own instructions and get better results with this valve. The valve is not the issue. A lot of guys out there will tell you that, oh, it's just a 5-liter Ford old technology valve, but if you get that GM valve on it, oh, it doesn't have these problems. It works great. Well, it's a different valve. Fine. They're not the same. But the issue is not the valve. It is the way Holley controls the valve with their current logic. And by following the recommendation I'm making in this video, there would be much better results with that valve, regardless of what you're trying to do with it. Now, I have a whole bunch of other things we're going to talk about in some future videos in the next few weeks about the rest of the logic I don't like on the idle air valve and what they should do to help that. But this is a very simple first step that allows your users to follow your own instructions to get better results with your product. And I can't think of an easier way to implement this without disruption and at a cost that's virtually pennies to you. Holley, if you would like me to send you this spreadsheet so you can know what the translations need to be in the code behind the scenes, I am happy to provide it to you. But I would recommend you do this with every valve, not just the Ford valve, but every valve you guys touch. If you're going to keep doing things based on idle air percentage duty cycle, you should linearize every one of these valves. I'm not a Chevy guy, so I can't speak to what those curves look like on all the other valves, but some engineer out there has that data. I happen to have it for the 5.0 Ford because that's what we do. But you should find them for every other valve out there and give people a very consistent experience from platform to platform, because that's the whole point of a standalone system. Is you should be able to not worry as much about what the specifics of your platform are and be able to tune in a similar manner and get similar results when it comes to stuff like this. And right now you cannot do that. So guys, I know that most of you will not fully understand the importance of this topic as I'm describing it here, but hopefully this registers with a few of you and you understand the benefits of going this direction, and lots more to come. So guys, as always, good luck. Godspeed.